Alright, so section 3.10 I think it is, we're going to work on polynomial and rational inequalities. So this is going to be trying to decide where something is, true. What values of x make this inequality true. Same thing is going to happen, except we're going to work with rational inequalities. That's going to be a little bit more involved, although we're going to start out with the easy stuff. We're going to start out with polynomial inequalities and kind of build up to rational inequalities. Before we really get started in this stuff, let me try and answer a question that might be in your minds, like, well, why would I care where this is greater than 0 or where this is greater than 1, that kind of question. Now, where this is greater than 1 is equivalent to where this polynomial is greater than 0, and answering those kinds of questions is something that you're going to work on in calculus because it has some neat answers. So let's take a look at a couple polynomials. This goes a little bit beyond our course. This is stuff you're going to work on in calculus, but it's just going to show you that people actually use the stuff that you're going to be learning right now. So if I wanted to know where this function has minimums and maximums, these points here and here, that's going to be related to where this polynomial changes signs. So for instance, if we factored this and set it equals 0, you'd figure out that x equals -2 and x equals +3. That's where this graph changes signs. So it goes from positive to negative to positive. Well, the behavior of this polynomial predicts the behavior of this polynomial. Where this function down here is positive, this function is increasing until we get to this point. And then that function starts decreasing until we get to that point. So where this crosses the x-axis tells me where I could have these points, these maximums and minimums here. So it's kind of a nice correspondence. Now that goes a little bit beyond what we're going to do, but I hope it does give you a reason to believe me when I say that people do use this kind of stuff. We have to investigate where things change their sign, where they're positive, where they're negative. And so that's where we're going to begin, is trying to figure out where is this greater than 0. Now, I've laid this out in 6 steps. We're going to follow along these steps. We're also going to do it on our graphing calculator because eventually the graphs of some of these expressions are going to look kind of on the ugly side, and it's not going to be so easy to look at the graph and figure out, well, where it's positive and where it's negative. So right now, what do you know about the graph of something like, say, y equals 6x squared plus x minus 1? What would that look like in general terms? Yeah. So Robert's giving us a little U-shaped kind of thing. That'd be a parabola. In fact, that parabola is down here. So if you wanted to look at that there, you've got it. So this is y equals 6x squared plus x minus 1. But let's actually play this along the way we're going to do it as we work through these things. The first thing we want to do is figure out where does this actually equal 0. And in the case of this one, this will factor. It factors into 3x minus 1 times 2x plus 1. And that gives us 2 possible solutions here, right? We've got one at 1/3, and then we got another one at -1/2. So those are our 2 solutions. And those 2 solutions break up the real number line into intervals. So let's write down what those intervals are. Those intervals would be everything from, well, let's see. Let's write this down. That's going to be our -1/2 to 1/3. So we're going to have an interval from -infinity to -1/2, and then -1/2 to 1/3, and finally 1/3 to infinity. Those are our intervals. The reason I want you to write down these intervals now is because 1 or 2 of these intervals are going to be your solution. That's what's coming your way, is one of these sets of points or 2 is going to solve this inequality. Now, we could actually probably do this based on the graph right here. And here we see where it crosses the x-axis. It crosses right where I said it would, at -1/2 and at positive 1/3. But take a look at the graph. To the left of negative 1/2, what can you say about the graph? Is it positive or negative? Is it above the x-axis or below the x-axis? It's positive, right? So it's positive here. How about between these two roots? Negative and then positive. You know the shapes of parabolas really well. That's not a surprise. You could do this one without necessarily really even writing down hardly anything at this point. But that's not my goal here. My goal is to get you into the habit of working through this and testing points. I just happen to start out with a nice easy one here to begin with. So if we want to figure out where it's positive, where it's negative, and we don't have reference to a graph or it's a complicated graph like we're going to get on the back side, then what we're going to do is we're going to test points in each of these intervals. These kinds of functions can only change signs at these points. So let's come up with some test points. Some points in each of these intervals that we can plug into our expression and test if they're positive or if they're negative. So our test points. What would be some test points in each of these intervals? Negative 1, 0,
1.
and 1. Sure. Now, you can choose any points you want. Just be careful that they're in the actual intervals that you need. Now, open up your graphing calculator, and let me clear out a little stuff here. Before we work on this problem, let me make sure that everyone's settings are correct. I want to make sure that your table set is correct. So hit the second key, then the window key. The lines that are important to me are these last two. You should have them set to independent, is set to ask, and dependent is set to auto. That allows you to input all the values that you need and just the values that you need. These other things don't make a difference to us right now. Before I do my table, I actually need to put in my function. So let me clear out this one and type in 6x squared plus x minus 1. Okay, so there's my function. Great. Now I want to test my points. So we're good right here. Everyone's got the function in. Let's go to the table. You can see table above the graph key. So if it's above there, then you need the blue key, the second key, to get to the table. If there's some values there already, just delete them. And now let's type in the values that Antonio gave us, negative 1, 0, and 1. Those are our test points. Now it doesn't necessarily matter if I got 4 or 4 million, negative 1 or negative 1,000, etc. What matters here is the sign of these things. And the signs tested out to be positive, negative, positive. That's what I'm looking for. That's the information that I need here. Because at the end of the day, I want to know, where is this greater than 0? So is that going to be the positive intervals or the negative interval? It's going to be the positive intervals. So here and here, those are your solutions. Those are the intervals that have the values of x, that if you put in a value of x from this interval into here, this expression is going to be positive. It's going to be greater than 0. So your final answer is just that. So the answer is negative infinity to negative 1/2 union 1/3 to infinity. Yay. And that's it. WebAssign, I don't know, you might have to use a comma between these two. Not sure.
If you use the union, you're fine, but I think you do need a comma.
There's a union.
There's a union symbol? All right, good on WebAssign. Appreciate them for using that.
There's also an upside down union symbol.
The upside down union symbol will be intersection, so that would be where they overlap. So you probably wouldn't want to use that one here. So, okay, not so bad. Now the reason that we do all this testing of points is because eventually the graphs get a little bit more complicated. And it's tough to see that. So let's look at example B here on your handout, on your other handout. And again, we've got an inequality. If I multiplied it all out, what would this be? What degree would I get here? Third degree. Yeah, you get a cubic inequality. Now, maybe you're good, maybe you're not so good with the graphs of cubic inequalities. You should know the end behavior, that kind of thing. But, you know, it's tough to figure out what these are like. I want to know when this is less than 0. So the first thing I'm going to do is I'm going to figure out, well, where does it actually equal 0? Where could it cross the x-axis? So I've got to solve x minus 6 times x plus 8 times 3x plus 8 and set that equal to 0. Now a couple of these should be pretty evident. For instance, where does this first term equal 0? Alright, so x equals 6, negative 8, and negative 8 over 3. So let's put those on our number line here. So we've got values at negative 8, and I guess that's to the extreme of my line here. Negative 8, 6, 8/3 is negative 2 2/3, so, you know, somewhere between these two. A little bit closer to the 3 than it is to the negative 2. So something like that. These points create intervals along our x-axis. So Pfeiffer, maybe you can help me out. I need some intervals here. What are these intervals going to be?
Negative infinity to negative 8.
Negative infinity, negative 8. Good.
Negative 8 to negative 8 over 3.
Good.
Negative 8 over 3 to 6.
Mm-hmm.
6 to infinity.
Nice. The reason I want you to put these intervals down now is because it's easy to get confused later. When you start throwing in all your test points, you might look back and confuse a test point with the endpoint of your interval. Some of these intervals, 1 or 2 of these intervals, are going to be the intervals that solve this inequality. Now before I start testing points and stuff like that, well, I guess I need to come up with some test points. Let's see. Ellie, how about some test points? What would be a point in each interval here?
Negative 10,
Negative 10, good.
negative 5,
Mm-hmm.
0, positive 10.
Perfect. Now you're free to choose any points you want, just as long as they're in those intervals. Before I start plugging those test points, can anyone think of something I need to do?
Plug it into the calculator.
Yeah, I got to plug in the new function into my calculator. So you got to clear out the old function. And I'll hit the clear button down here so you can follow along with my keystrokes. So I'm just going to type it in as it's written for us there. Left parenthesis, x minus 6. Right parenthesis, left parenthesis, x plus 8. Right and left again, this time 3x plus 8. Looks good. Now we can go to our table. So to go to the table, hit the second key, then the graph key. Let's delete all those values there so that we don't get confused. And then we'll just type in all these values for ourselves. Negative 10. Negative 5, 0, and 10. Nice. What's the relevant information that I need out of this? Positives and negatives. Good. So let's keep track of what we ended up with. I think it was negative, positive, negative, positive. Is that right?
Yeah.
Yep. All right. So let me write that down here. Negative, positive, negative, positive. Looking good there. So Rachel, here's a question for you. Which one of these intervals do you think satisfies the inequality? The negative intervals or the positive intervals?
Well, it says is the equation is less than 0.
Right, so the important thing to see is that it's less than 0, so
Negative.
yeah, we want the negative ones. So our solution is just going to be these negative intervals. Solution. And that's going to be negative infinity, negative 8, union negative 8/3 to 6. Wow. That wasn't so bad. Let's keep it rolling with example C here. So let's take a look at example C. Now, one thing that's going to change is that you're going to start getting intervals that have a less than or equal, inequalities that have a less than or equal to or greater than or equal to. If I had a less than or equal to here, how would that change my answers? Can you parse that out? What would change about this if we had a less than or equal to as opposed to just a less than? Yeah, I need brackets on anything that wasn't infinity or negative infinity. Let's take a look and see why that's true. So if I had a less than or equal to and I put in a negative 8, oh, 0. Well, 0 is less than or equal to 0, so that would work. Likewise, I could also put in negative 8 divided by 3. That should also give me a 0. So anything that gives me a 0, if I'm looking at less than or equal to 0, then I can include those endpoints. So I'll include those. Now, one thing that you might be noticing is a little bit of a pattern in your answers here, right? Negative, positive, negative, positive. We saw that in our first one. We see it in this one. Generally, that's going to happen, but not always. So you're still going to have to play it kind of honest and do your testing of points on your exams. I'm going to ask to see these points. I'll give you a little table to fill it in. I want to know your test points, and I don't care the number. I just care the sign, either positive or negative. Let's move on down to example C. And maybe just for giggles and for practice, let's make that a greater than or equal to here. Just for the extra practice. Oh, and I guess I was already anticipating myself there. All right. What's the first thing we should do?
Make it equal to 0.
Yeah, let's solve where it's equal to 0. Thank you, Josh. So, so x plus 5 squared times x plus 2 times x minus 1. I want to know that it's greater than or equal to 0. Can you read off where that's going to equal 0? Meredith, some help? Where is that going to actually equal 0? What values is this going to equal 0? So let's put those numbers on the number line. Thank you so much. So negative 5, negative 2, and 1. And I'll squeeze those in here maybe. Negative 5, negative 2, and 1. That gives us some intervals. So, Robert, what do we get for intervals?
Intervals, we get negative infinity, negative 5, negative 5 to negative 2, negative 2 to 1, and 1 to infinity. And we have brackets on all of those.
Yeah. So
Besides the infinity sign.
beside the infinities, the rest of them are going to get brackets. So I'll just put them there right now, do my thinking ahead of time. So that way, when I'm done and decide what signs get which, I can figure out, I'll have my answers right here already. Ellie?
Wouldn't the -5 occur twice?
It does occur twice, but it's still only a root once, right?
Okay.
So it's a great question. And there'll be something interesting that happens here at the -5. But let's come up with our test points first. So, Alex, how about some test points for us, please? What would be some good test points?
-6,
All right, -6.
-4,
Mm-hmm.
0, and 2.
Perfect. Perfect. Let me put that into my graphing calculator. I've got to change my equation. So I'll just clear this out. X plus 5. And hit the squared key. Why not? X plus 2. And X minus 1. Great. Now let's go to our table. Delete all our values here so we can choose Alex's points. -6, -4, 0, and 2. Nice, nice. Elizabeth, what information am I going to look for from this table?
You want to see the positive and negative?
Yeah, positive and negative. That's all I care about. So this one's kind of strange. It's positive, positive, negative, positive. So that kind of messes things up a little bit from our usual pattern. What we've seen for the first couple are plus, minus, or the other way around, but they alternate. So let's just double check it again. It was, yeah, plus, minus, plus. Cool. So, this one's kind of interesting in terms of its answer. Since we're looking for where this is greater than or equal to 0, then, well, where is it greater than or equal to 0?
On 3 things, so we'll get 2 units.
Yeah, so this one, and this one. The interesting thing is if you put these things together, and you can, because you've got a parenthesis or bracket here, right? So really you get negative infinity to -2, and then 1 to infinity. So that would be the answer for the greater than or equal to case. It'd be negative infinity to -2 union 1 to infinity. Basically, you're just throwing out that interval.
Would it be worse wrong if we did it?
No, I wouldn't. If you gave me all 3 of these, it's not wrong because you're still including the 5. But maybe we'll take a look back for a second and think, well, what if I didn't have a less or a greater than or equal to? What if I just had a greater than? If you had a greater than, then I want you to think about -5. If my inequality was a greater than, could I use the -5?
No.
Why not? If you put in -5, you'd have 0 times something times something. Well, 0 times anything is going to be 0. Is 0 greater than 0? No, so you couldn't use that one. It wouldn't work. So your answer without the inequality, without the greater than or equal to part, would just be negative infinity to -5 union -5 to -2 union 1 to infinity. So that would be for the greater than case. Would be that. So you'd be dancing around that -5. With the greater than or equal to, you close those brackets and you can actually use the -5. So a little subtle difference on that one. So far, so good with these? Please? Okay. Let's take a look at the backside. So between the start of class and now, I've gotten meaner, and now you get these other hard ones to deal with. Let's take a look at what's going on with the backside. This is a rational inequality. Graphs of these things are even messier than the graphs of our polynomials. So it's nice just to remove the graph from the picture altogether and just work on and rely on testing points. the first thing you have to do with your rational inequalities is get 0 on one side. All right, so that's not too bad. You just move the 3 to the other side, and now you've got a 0 over there. But then, some work that I didn't ask you to do in your Math 1150 class, but you do have to use here, is this. Write the inequality using one fraction. So you just got to get a common denominator here. So you think of that 3 as being 3 over 1, and you say, okay, well, my common denominator is going to be this. You multiply by 1 to get that common denominator. Be careful to distribute a negative 3 to both terms. What am I going to get over here? When I simplify this, what was this going to equal?
Negative 5x plus 7.
Yeah, thank you. A couple of voices on that one. Appreciate them both. Negative 5x plus 7. This is where your work starts. And it should start to feel and look a lot familiar with what we did originally. So before we go on, are we okay with these first couple steps? There are going to be some problems when you're going to have to do this. And if you do have some, great. Just move everything to one side and then write it with one fraction. So let's pick it up from here. Where it's going to start to seem familiar is after these first two steps, you're going to have to find the roots of the numerator. So that's where negative 5x plus 7 equals 0, and the roots of the denominator. 2x equals 1, x equals 1/2. So that's the roots of the denominator. What are the roots of the numerator? Well, I'll leave the 7 over here and move the 5 to the right-hand side, the 5x to the right-hand side. Why am I moving that negative 5x term to the right-hand side? Yeah, it gets rid of the negative sign. No, you can move it the other way. If you did it the other way, you'd end up with negative 5x equals negative 7. The thing that I find is that it's easier to make mistakes with more negatives. So that's why I try and avoid them. But you get the same thing either way.
Shouldn't the 2x minus 1 be a 2x plus 1 actually? Because of it changing from that to that side, or am I thinking
No.
the other problem?
You might be thinking of a different problem, but the 2x minus 1 was consistent all the way through. That's your denominator. It's your denominator here and here and here.
Oh.
And so we need to know where the denominator is 0, so that's this part right here, and where the numerator is 0, which is that part there. The rest of this is going to look pretty familiar, at least I hope. We're going to put in these two numbers on the number line. The 1/2, of course, is going to go here. The 7/5 is going to go here. Now I want to know where this is greater than or equal to 0. There's one catch, one difference. Which one of these can't I use in this expression? Which value? X equal 1/2 or x equals 7/5? Ooh, I had two hands. Go ahead.
X equals 1/2.
X equals 1/2. Good. Why?
I was also going to say why, because it's in the denominator. Yeah.
If you put it in a 1/2, you're going to get 2 times 1/2 is 1, 1 minus 1 is 0. You'd be dividing by 0. You can't use the 1/2. So 1/2 is not part of our solution, period. So when you're setting up your intervals, let's take account of that. Now, can you use 7/5? Yeah, 7/5 will give you a 0 in the numerator. It's okay to have 0 in the numerator. It's not okay to have 0 in the denominator. So our intervals would be negative infinity to negative or to 1/2, parenthesis again 1/2 to 7/5. But I can use 7/5. So what should I do different here? Put a bracket and then bracket 7/5 to infinity. I need some test points. So Nikki, how about some test points?
-1,
Sure. -1, -1, 0.
and 1.
Actually, 1 would be here.
3.
3, sure. If you're not sure of value, you can do a couple things. You could take out your calculator and get a decimal, or you could just choose a value that's like, all right, I know 10 is bigger than that, and just, work it that way. Let's put this expression into our calculator. This is the expression that you have to put into your calculator, the one that has 0 on one side. So let's kind of highlight that. That's what you put into your calculator. Yay. So let's see what happens there. Lenora?
Wouldn't 0 not work in the second interval?
Oh yeah, you're right. Good call. Good catch. Yeah, 0 actually happens to be over here. So we need a different one. So let's look at some decimal values here. This is 0.5 and this is 1.4. So I need something between these. 3/4. Sure. Now I'm going to do this. I'm going to use 0.8 because that way I don't have a little messy handout, right? I don't have to scratch over everything. Okay. So as far as putting this in your calculator, we got to be a little bit careful. I'm just going to delete all these values here for the moment. Hit the y = key. You've got two options. Either one is fine. The first one can be used by anybody, and that is put parentheses around the numerator, -5x plus 7. Whoops, I forgot the x. So let's insert there, insert the x. So -5x plus 7 divided by parentheses 2x minus 1, like that. And that's great. If you're not really keen on those parentheses and such like that, then there's an alternative. If your calculator is a up-to-date TI-84, and by up-to-date I mean its operating system is up-to-date, you can hit the alpha key, then the y = key, and then press enter. That'll give you a numerator and denominator. Now you don't need parentheses. -5x plus 7 and 2x minus 1. Just out of curiosity, what preference do you guys have? First one or the second one?
Second.
Second one? Okay. Second one's kind of nice. It will make a little subtle difference when we get to the table, but you'll be able to see both of those when I get to the table. Second table, let's plug in our values. So that'd be -1, 0.8. You can use 0.75, that would work as well, and then 3. So the subtle difference is that where it can, your calculator will give you a fraction as opposed to a decimal. Now if I pick something, kind of way out there like, say pi, I'll get decimals for both of them. But it's still telling me the same thing. It's still telling me negative, positive, and negative. That's, in the end, that's all I really need to know is negative, positive, negative. So, negative, positive, negative. Which interval or intervals do I want?
Just the positive.
Just the positive one. Yeah. And in fact, because we were careful with our endpoints, this is our answer. We're all done. Right there. So your answer is the intervals that test true. The interval that say, yeah, I wanted to know where this was greater than or equal to 0. It's positive in this interval. So 1/2 and 7/5. Like that. By the way, here's the graph. It's not that easy to answer these questions based on the graph. You could, I suppose, but I wouldn't try. Comments on this one? Yes?
So why is the 1/2 of
That's a great question. I appreciate you asking. Let's go over to our table. Do me a favor. Type in the 1/2. And tell me what happens when you type in 1/2. Error? Wait a minute. Did I do something wrong?
No.
No. Good answer. Good answer. I didn't do anything wrong. No, what's wrong is that by putting in 1/2, that puts in, effectively it puts in a 0 in the denominator. And you can't divide by a 0. So what your calculator is telling you here is like, no, you can't do that because the function's undefined here. Now if we put in 7/5, we actually included 7/5 as part of our answer, right? If you put in 7/5, you get a 0. Well, 0 is greater than or equal to 0, so that's why we're including the 7/5. But the 1/2 got a parenthesis because it creates an error, because it's not defined at that point. Yeah, you're dividing by 0. So that's exactly why we're including the 7/5, but not the 1/2. Perfect. Just a kind of a quick FYI. There's 2 points at the end of your problem. If this was a 7-point problem, there's 2 points just for getting this part correct, getting the parentheses and brackets correct, because you got to be careful about that. So, are we good with that one? All right, thank you. Let's move on down to the next one. And we've got a couple more here. I might just split this up into 2 parts. We'll work on this one maybe a little bit faster. Example E, 2x plus 3 over x squared plus 4x minus 21 is greater than or equal to 0. Now I'm not sure if it's a problem that we're going to get to today, but I will give you a heads up that occasionally they'll give you a denominator here that won't factor. What's that going to mean for you? Well, let's take a look at this one. I'm going to start out with where the numerator equals 0. Where does the numerator equal 0? All right, so negative 3 over 2. Then I need to know where the denominator equals 0. So that's going to be x squared plus 4x minus 21 equals 0. Suggestions? Should we pull out the quadratic formula for that one? No?
Can factor it.
Yeah, we can factor it. Factoring is your first choice. So, let's see. Say, how's this one going to factor?
X positive 7, negative.
Good. So that gives me 2 solutions, negative 7 and positive 3. Awesome. Let's put those on the number line. So let's draw ourselves a quick little number line. So I've got a negative 7, negative 3 halves, and a positive 3. So that gives me some intervals. Which ones can't I use? Which values of the x's here cannot appear as part of my solution? I got to vote for negative 7 and 3.
Yeah,
Good. Why?
because it makes the denominator 0.
Yeah, on fire. Well done. Thank you both. It makes the denominator 0. So negative 7 and 3 are going to get parentheses. So it's going to be negative infinity to negative 7, parenthesis, negative 7, parenthesis, to negative 3 halves, bracket. You can use negative 3 halves, so that one gets a bracket again, to 3. And 3 is going to get a parenthesis, and so is infinity. I strongly suggest you write these down here, because when you start plugging in the points you need to test, people get all messed up with their points and the endpoints of the interval, and they mix up things, etc. So right now, these intervals represent our answers, our potential answers. Okay. Jaya, what will be some test points for us, please?
Negative
Mm-hmm.
negative 5,
Good.
2,
Sure.
and 4.
Perfect. Perfect. So let's put those in. We've got to change our function in our calculator first. So let me delete all these other values just so that I don't get confused with those. Go over here and clear these out. Since most of you seem to like my little alpha and then y equals trick, let's do that. Alpha, then y equals. You can see that down here, then press enter. So that gives us a numerator and denominator. 2x plus 3 divided by x squared plus 4x minus 21. When you get that all set, then you can go to your table and plug in some numbers. So let's plug in those numbers that Jay gave to us. Negative 8, negative 5, 2, and 4. Now I guess the downside is that you're getting fractions, but it doesn't really matter because what information am I looking for in column Y1?
Positive and negative.
Positive and negative. And if it's fractions or not, doesn't really matter. It's still showing you positive or negative. We're going back to that repeating pattern. Negative, positive, negative, positive. Which intervals do I want? The positive intervals or the negative intervals? Positive, yeah. I want to know where this is greater than or equal to 0. Now the nice approach that we took is helping you out right now, because now we're all done with this. It's this and this. Those two are your answers, and there's no more thinking. Those are the positive intervals. We're not going to include the 7, excuse me, the negative 7. We're not going to include the 3. So the answer is negative 7, negative 3 halves, bracket, union, 3 to infinity. WebAssign is picky. I was getting some feedback, shall we say, from one of my calc students, because they're like, wait a minute, you know, it's telling me I'm wrong, because this person forgot the appropriate bracket or parenthesis there. So do be careful with that. These are extra points that I want you to get at the end of the problem. So, all right. How are we looking there? Doing okay so far?
Mm-hmm.
All right. Let's keep going. I'm just going to make mention out of a couple things here. I am going to finish this section up before we take a break here. Let's look at this one. So, example F. X over x squared plus 2x minus 1 is less than or equal to 0. So we'll divide up the labor in this one. We need to know where the numerator equals 0 and where the denominator equals 0. So that's going to mean x equals 0 or x squared plus 2x minus 1 equals 0. I'll solve where the numerator equals 0. You solve where the denominator equals 0. Fair enough?
That's fair.
It's a fair division of labor. What's going to be a pain about this down here? Yeah, it doesn't factor. Man, WebAssign is mean. The good news is that your instructor is nice. I'm not going to give you, these problems are long enough, I'm not going to give you something that doesn't factor, but you will see something like this in your homework. So, yeah, if it doesn't factor, then what could you do? Quadratic formula, yeah. Oh my. A is 1, B is 2, C is negative 1. So it's going to be x equals negative of 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 1 all over 2 times 1. So negative 2 plus or minus the square root of 4 plus 4 over 2. Or negative 2 plus or minus the square root of 8 over 2. And you think you're done here. Sorry.
Wait, but can you factor out a square root of 4?
Yeah, you can. So you can rearrange this as the square root of 4 times the square root of 2. And the square root of 4 simplifies, right? So negative 2 plus or minus 2 square roots of 2 over 2. Now there's a lot of 2's in this problem. Too many if you ask me, but that's the way it worked out. My suggestion in terms of cleaning this up would be to do this. Split it up. Take negative 2 over 2 plus or minus 2 square roots of 2 over 2. Now you don't have to worry about canceling or factoring so much. Now you can just simplify this right away. It's going to be negative 1 plus or minus the square root of 2. So, whew, a lot of work there. It might be helpful for you to figure out, well, what's, negative 1 plus the square root of 2. What's that? Well, that's about 0.414. What about negative 1 minus the square root of 2? Oh, well, that's about negative 2.414. And the only reason for that is because you're going to have to come up with some test points. And you need to know, well, where are those test points? Okay. Let's see here. I need a number line. Let's look at it. So I've got a point at 0 and another one here at negative 1 plus the square root of 2 and negative 1 minus the square root of 2. Now it might be helpful, like I said, to keep in mind that that's about 0.414 and this is about negative 2.414. And the only reason for that is just so that we can come up with the appropriate test points. Am I going to be including the negative 1 minus the square root of 2 and negative 1 plus the square root of 2 in my final answer? No, because that's where the denominator is 0. So this is going to be negative infinity, negative 1 minus the square root of 2, parenthesis, negative 1 minus the square root of 2, with a parenthesis again. How about the 0? 0 gets a bracket. Bracket on the 0 again. Negative 1 plus the square root of 2, which gets a parenthesis. So the only thing that's getting the bracket is the 0. Okay. Gavin, I need some test points, please. And you can give me decimal values. It doesn't have to be real nice, easy numbers, whatever works. Two-thirds would actually be over here. Take a look. This is 0.414. What's something a little bit less than 0.4? 1/8. What else? Go ahead, Gavin.
1/3.
1/3? Sure. 1/3. And then one over here. 2. Sure. Those would be some good test values for us there. All right, thank you. Let's clear out these old values. and then put in our new function. So I'll clear that and go back to x over x squared plus 2x minus 1. Let's plug in our test points here. So we'll go up to our table. Thank you, Gavin. -3, -1/2, which I'm just going to type in as -0.5. 1 divided by 3. Now when you type in 1 divided by 3, it'll replace it with a decimal value. That's okay. And then finally 2. All right. Zaid, what information am I looking for from this table?
Values that are lesser than or equal to 0.
Yeah, I want to know where this is less than or equal to 0. So if we put in those signs, it was negative, positive, I think. Let me just double check back here. Yep. So negative, positive. So we want the roots, we want the intervals where this tests out negative, because that's going to be where this is true, is where they test out negative. So that's going to be this one and this one. So nice work that we did ahead of time. It means we're all done now. We just got to copy those for our answer. We've got answer is negative infinity, -1 minus square root of 2, union 0 with a bracket, and -1 plus the square root of 2, parentheses. I'll promise to be a little bit more gentle than this on an exam. Those problems are long enough as it is, so, you know, but you will see some in the homework. All right. Comments or thoughts on example F? We've got 2 more. I'm actually just going to hint at what we're going to do with example G, and then we'll work on example H together, because that's going to require some numerical work. Work with your graphing calculator. So for example G, they want to know where the graph of F lies above the graph of G. That's equivalently, that means where 1 over x is greater than 1 over x minus 1. So that's the way to start on this one. Now we haven't had to do this since our first example, but what you would have to do here is move this to the other side, and then you have to write this with common denominators, right? So you'd have to write it with a common denominator. Our LCD here, LCD would be x times x minus 1. You have to regard this as one whole term. X times x minus 1, 1 over x minus 1 over x minus 1. So to get that common denominator, I'd multiply this by, say, x over x. That's effectively multiplying by 1. What would I multiply this by? X minus 1 over x minus 1. So I get x minus 1 over x minus 1 times x minus x over x minus 1 times x greater than 0. Now you can bring these two things together. You'll end up with 2x minus, excuse me, actually, no, just minus 1, right? Because the x's will cancel. Minus 1 over x times x minus 1 is greater than 0. And then you can solve it from there. All right, you need to do your test point thing. There's no roots in the numerator. This never equals 0 in the numerator. So the only roots you're going to get are in the denominator, and go from there. Your solution should match what you see in the graph. All right. Last one, a nice applied problem. A highway engineer develops a formula to estimate the number of cars that can travel safely on a particular highway. She finds that the number of cars that can pass any point per minute is modeled by this function. If you want the number of cars passed by the point to be 40, what range of speeds can support that travel? So, okay. Basically, we want to know where this is at least 40, greater than or equal to 40. So what we're going to do is we're going to graph two things. We're going to graph this, y equals 40, and this is y equals h of x. Let me call these points A and B. Where is the graph of h greater than the graph of 40? In other words, where is this going to be true?
Between A and B?
Yeah, between A and B, right? Starting at A, going up to B, this graph is taller than this one. So the thing that you're going to have to do is use your calculator to find those 2 points, and that's what I'm going to help you out with now. Take out your calculators. Let me delete these old values here. Clear that up. I'm going to put in 2 equations. The first one's going to be my h of x. So that was, let's see, we'll do the alpha y equals trick again. 88x divided by 17 plus 17 times x over 20 squared. Now to do that last part, I'm just going to put in a left parenthesis, x divided by 20, close parenthesis, and then hit the squared key. Great. So that's the first part. Is everyone able to get that part in okay? All right, thank you. Let's move down. And then the second part is a 40. Because I want to see where these graphs intersect each other. Now, one of the things that you're going to have to face as a challenge is to figure out where to graph it. But at least in this case, there's a good hint. What would be some good ranges upon which to graph this? Any ideas, any at all? Anything inspiring?
0 to 50 and 0 to 50.
Yeah, 0 to 50. All right. You don't have to, yeah, we'll go a little bit higher, maybe 60, just so we catch that maximum there. So, good thinking, Robert. So, 0 to 50 on the x-axis. I probably don't want to leave x scale equal to 1 because I don't want to see 50 tick marks. That would be like annoying. How about 5 or 10 or whatever works for you? On the y-axis, let's go from 0 to 60 for Robert's suggestion. And, you know, this time you could use 10 or 15 or 20, whatever works for you there. When you get these window settings, hit the graph key. Should give you something like this. We need to find those points of intersection. Does anyone remember what we did in class before this?
Table intersection.
Yeah. It's right underneath here, the calculate menu. Hit the calculate. So second calculate. Let's do intersection. Now it's a little bit annoying the way these are set up. But let's get close to our point of intersection. And once you get close to your point of intersection, right now I'm on the first curve, you have to press enter a total of 3 times. It's a guess from your first curve. Oops. Oh, no. I didn't do that. Ah. So let's go back here. 5. So it's a guess from your first curve. Press enter. Second curve. Press enter. And it wants another guess. Just press enter. And it should give you that intersection point. So about 0.9454. We'll round it to 3 decimal places. So 9.454. And then let's do the same thing over here for that second point, second calc, intersect. If you had a good guess, you could use that. So let's see, 10, 20, 30, 40. So I'm going to guess 40. I'll just type in my, oh, it doesn't like that. Never mind. On the trace button, it allows you to do that kind of stuff. So get somewhat close, and then press enter a total of 3 times. 2, 3. So 42.1 or 42.311. So as far as your answer is concerned, it'd be this 9.454, comma 42.311. My final question for you is brackets or parentheses?
Brackets.
Michael says brackets. Nora's nodding her head saying, yeah, I agree with that. Why should we use brackets?
Greater than or equal.
Greater than or equal to. So you can include the point of intersection because at that point, these two things equal each other. So we'll use the brackets and we're done. Whew. Nice. How many people were able to find those intersection points on their calculator? All right. Good, good. That's something I expect, and I'm glad to see that everyone's able to get that. If you're having problems with your graphic calculator, please come see me. I'm pretty good with those. All right, that's it for this section.